We're going to look today at the non-calculator portion of our Chapter 4 review. These are all things that you should be able to do by hand. The first couple are graphing ones. It says to graph each of the following, identify the parent function and graph it, and then deal with the transformations. State the domain, the range, and the asymptote, and graph it as well. So our first one is a pretty basic one, y equals 3 to the x. This is just a basic exponential growth curve. So we're going to make a t-chart. We're going to select a couple different x's, let's say -2 up to +2, and taking 3 to each of those powers. So for example, 3 squared is 9, 3 to the first is 3, anything to the 0 is 1, 3 to the -1, that gives us the reciprocal, so we have 1/3, and then 3 to the -2 is going to square it and give us the reciprocal, or 1/9. And remember that relationship between those two. The negative version just makes the reciprocal of the positive version. All right, so plotting those points, we have -2 up 1/9, -1 up 1/3, 0, 1, 1, 3, and 2, 9. All right, again, just a basic exponential growth curve. All right, now it asks us to list the domain, range, and the asymptote, and to also graph that asymptote. So what you should be seeing is that your curve is leveling off right above the x-axis. So our asymptote equation is just y equals 0. Our domain is everything. In other words, we're allowed to pick any value for x, positive, negative, fractions, 0, any of those. So -infinity to infinity. And then our range is everything we get out for y. And from our graph, we can see that those are all values above 0. So from 0 to infinity, but not including 0. Now our second equation uses the same parent function as we had in example 1. So we have y equals 3 to the x. Here we have y equals 3 to the x minus 2 plus 1. So we want to identify the transformations of that parent function, y equals 3 to the x. So the -2 here by the x is going to cause it to move right 2. And then the +1 at the end is going to cause it to go up 1. So we're actually going to start with those same points that we just plotted. All right, so take a minute and get those put on your paper. And we're going to take those points and we're going to just shift them right 2 and up 1. So the top point here, right 2 and up 1 would land here. Right 2, up 1. And we're going to continue to do that for each point. So what happens now is because we've shifted all of our points up 1, our asymptote is actually going to be up 1 as well. So we're going to have a horizontal asymptote right there. The equation for that would be y equals 1. And then our curve is going to approach that asymptote on the left-hand side without actually crossing it. So domain, again, is everything from -infinity to infinity. And our range is everything above 1. All right, questions 3 and 4 are also tied together. If you look at them, question 3 is going to give you the parent function here that we would now then use in question 4. So we're looking at graphing y equals log base 2 of x. The trick to graphing log equations is to actually rewrite them exponentially. So we start with our base, we say 2 to the y power equals x. And because of the way this is set up, we have y as our exponent. We're actually going to select y values instead of x values. So let's go from -2 to +2, but now these are our y values instead. All right, so again, let's start at the bottom. 2 squared is 4. 2 to the first power is 2. 2 to the 0 is 1. 2 to the 1/2 gives us the reciprocal. Sorry, 2 to the -1 gives us the reciprocal of 1/2. And then 2 to the -2 is going to square it and give us the reciprocal 1/4. All right, so plotting those points. We are to the right 1/4 and down 2, right 1/2 down 1, the point 1, 0, 2, 1, and 4, 2. All right, so this is a typical log curve. It's going to come up along a vertical asymptote, which in this case is our y-axis, and it's going to curve off to the right-hand side. So asymptote this time would be x equals 0. We're going to have a dotted line, vertical asymptote right there. And the domain now is limited. We can't go past that vertical asymptote. So our domain starts just above 0 and moves to the right. But our range now is all real numbers from -infinity to infinity. All right, question 4. We are going to start with the same parent function that we had in question 3, y equals log base 2 of x. So we're going to start with those same points. Take a minute and get those graphed. But now we have to identify the transformation we've done. And in example 4 here, this plus 3 next to our x is going to shift it left 3, and the minus 4 at the end is going to make us move down 4. Now because we have a vertical asymptote, if we shift everything right or left, that vertical asymptote moves as well. So our points here are going to move left 3 and down 4. And our vertical asymptote is also going to shift 3 to the left. So our asymptote would be at x equals -3. Our graph is going to curve along that vertical asymptote and off to the right-hand side. Our domain then would be everything to the right of -3, and our range would be all real numbers. Okay, so just keep in mind that log graphs and exponential graphs are just inverses of each other. In other words, reflections over that line y equals x. And so all of our xy ordered pairs just flip-flop. Okay, so in the first two, the exponential equations, domain was all real numbers, but range was limited. And now for our log graphs, it's just the reverse. Domain is limited and range is everything. All right, question 5 and 6 say to expand it completely. Now remember, you can take this in several steps if you want. Don't try to do every little piece all at once. We are expanding log base 6, and if we look at this, we have all three of our properties involved here. We have multiplication, we have powers, and we have division. So all of those are going to have to be pulled apart. Remember, addition is what happens when we pull apart multiplication. When we pull apart division, it turns into subtraction, and powers get moved to the front as coefficients, and we multiply those in. So we're going to expand this out. We have log base 6, and each of these multiplications here are going to get pulled apart as addition. So log base 6 of 36 plus log base 6 of x squared plus log base 6 of y cubed. And then the two pieces that we are dividing by, we have to subtract those out when we expand. So we're going to subtract log base 6 of 5. And we are also dividing by that quantity x plus 1. So we're going to subtract that off as log base 6 of x plus 1. And then our last step would be to distribute those powers to the front, and also to simplify any constants like this log base 6 of 36. That one we can break down. 6 to what power gives us 36? That's just a 2. So log base 6 of 36 is 2. Our powers here, this 2 is going to move to the front. We're going to get 2 times the log base 6 of x. The 3 will move in front. We get 3 times the log base 6 of y. And the last two don't have any powers, so there's nothing left to simplify. We're just going to bring those two pieces down. Here at the end, we have a quantity x plus 1. We cannot pull that apart. We do not have any rules for expanding the sums, just products, quotients, and powers. All right, question 6. We are taking log base 3 again. I see powers, I see multiplication, I see division. So we're going to pull all of that apart. We're going to have log base 3 of the x to the 5th. We have multiplication here, so it's going to pull apart as addition. So log base 3 of the cube root of y minus 4. And then again, we're dividing by a couple pieces, so those get subtracted when we expand. So minus log base 3 of 9 to the 4th and minus log base 3 of z to the 5th. Again, both of those get subtracted because originally they were division. Simplifying, our 5 is going to move to the front as a power here. So 5 log base 3 of x. The cube root is really a 1/3 power, so when we expand that, we're going to have 1/3 log base 3 of the quantity y minus 4. The third piece here, we have a 4 that can be moved to front, so minus 4 log base 3 of 9, and minus 5 log base 3 of z. And there is one more piece that we can simplify right here. Log base 3 of 9 is just 2, since 3 to the second power is 2. So this really becomes a negative 4 times 2. So final answer, 5 log base 3 of x plus 1/3 log base 3 of the quantity y minus 4. We said log base 3 of 9 is 2. 2 times negative 4 would be negative 8. And then our last piece, minus 5 log base 3 of z. All right, our next couple are just the reverse. Now we're asked to condense these. So any numbers that were moved to the front are going to get put back as powers. Anything subtraction is going to go back as division, and any addition between logs is going to go back as multiplication. So I see some powers here. I'm going to put the 3 back, and I'm going to put the 7 back. So I have the natural log of x cubed minus the natural log of the quantity x plus 4 to the 7th power. And then when I condense this down, I get rid of the multiple logs here. I just have one natural log in front. I have x to the 3rd on top, and because it was subtraction, it means it was division originally. I have the x plus 4 to the 7th piece on the bottom. All right, last one. We have 1/2 times this whole quantity, everything in brackets. So let's condense the piece in brackets first before we try to put that power back. So if we condense this, because it was addition here, it's going to condense to multiplication. So we're going to have an x times an x minus 3. We can go ahead and put our powers back for this one. So minus log of y to the 4th and minus log of x plus 1 to the 3rd. All right, now the 1/2 in the very front is really a power that's going to go back, but it's going to go back over both that x and that x minus 3. It's going to go back as a square root. So we have log of the square root of x times x minus 3. Log of y to the 4th minus log of x plus 1 cubed. And now I can condense all of those logs back into 1. So we're going to have the common log, and because I see subtraction, I know that there's division originally. In the numerator position, I'm going to have that square root of x times x minus 3. Both of the second pieces are subtraction, which means originally they were division. So I'm going to have y to the 4th on the bottom, and I'm going to have the x plus 1 quantity cubed also in the denominator. All right, so a couple days ago, we took a formative quiz where you did a lot of work without a calculator, simplifying or just evaluating logs. So make sure you go back and review how do we evaluate logs. without a calculator. All right, things like log base 5 of 25. We should know automatically that that is a 2, since 5 to the second power would give us 25. So things like that, all of those rules about logs, all of our properties for logs, make sure you take some time to review that as well.